This video is going to focus on the relationship between solute and solvent and the relative amounts of those. And we describe that by concentrations. Okay, so concentration, we can just very broadly describe it as a ratio between the amount of solute to the amount of solvent or the total amount of solution. Okay, so that's all a concentration is. It tells us the ratio of what's dissolved, how much is dissolved in a total solution amount. We can describe this in various different types of concentration units. They just change what the ratios are looking at, right? So in lab, we've already seen this relationship between like percent by mass, percent by volume. And so that's the mass of the solute per 100 grams of solution or mass of solute per 100 milliliters of solution. So that's why we say it's per mass or per volume. We've used molarity a lot, right? We've described this relationship between moles of solute per liters of solution. And there's two other concentration units that we haven't used that much that we're going to discuss in this video to see how we relate them to these other variables, okay? So molality is very distinctly different from the rest of these in the fact that, okay, it's moles of solute, but now it's per kilograms of very important solvent. Okay, so you notice each of these is relating the amount of solute per solution, total amount. Okay, so the solution is the solute and solvent together. Here, molality is just looking at the ratio between moles of solute per kilograms or amount of solvent. So we're ignoring the amount of solute in that instance when we're talking about our denominator here, okay? And then our mole fraction is basically the moles of one substance. So usually A is like our solute per the total number of moles. So that'd be the moles of our solute, solvent, maybe there's other solute particles, okay? And so we see that these are two we're going to use when we talk about colligative properties. And we're going to see that it's important that we use molality or mole fraction when we talk about these colligative properties. Now, before we get to colligative properties, we want to make sure that we can get to a relationship between these or convert between them. Because sometimes you'll be given, here's a solution that you measure or you know is some concentration in molarity or some percent by mass, and you maybe need to convert between those. So I want to look at that with an example of looking at sodium chloride. So let's say we have a 8.3% by volume sodium chloride solution. Now with this solution, what we want to do is we want to figure out what is the molarity of the solution and also the molality of the solution, okay? And so let's start with our first one and see how can we convert to molarity. Well, if we go and kind of rewrite this similar to what we have over here, we can say this is 8.3 grams of sodium chloride per 100 milliliters of solution. Well, we want to get this into units of molarity. So we want to get it into units of moles of solute, so moles of sodium chloride per liters of solution. Well, first what we can do is we can go ahead and convert our grams to moles using the molar mass, 58.44 grams of sodium chloride per mole of sodium chloride. And now we'll notice that we have the correct units that we want for the top of our ratio, right? Moles of solute. And then we need to have milliliters of solution converted to liters of solution. So we can go ahead and we'll see 1 milliliter of our solution is 10 to the negative 3. That's what milli means, liters of our solution. And we end up getting a 1.4 molarity solution from this. We'll go ahead and we see our units cancel out here, and we end up with moles of sodium chloride per liter of solution. Now, as I'm writing these out, you'll notice I'm being very explicit in the grams of what, milliliters of what, or moles of what. Because we see, if we don't do that, we can get very confused, and maybe we'll cancel out the grams of something that should be our solute when it's dealing with our solution, or vice versa. We're going to see that's important when we do our next conversion here. So this is very straightforward. We're just changing the ratio between these. Well, now what we want to do is we want to get to the molality of our solution. Well, again, if we look at molality, we're going to notice that we're going to need to get to grams of sodium chloride, the ratio per kilogram of our solvent. Well, this is an aqueous sodium chloride solution, so that's going to be kilograms of water, which is our solvent. Okay, so if we go back and we look at what we start here, we start with our 8.3 grams of sodium chloride per 100 milliliters of solution. We notice that we cannot do a direct conversion between those two because this is milliliters. We can't just change the units using density or something to kilograms of water because the solution, that includes water and our sodium chloride. So we need to account for this in some way. Well, before we can get to this ratio, what we want to do is we want to get to the volume to the mass of our total solution. Excuse me, this should be moles of sodium chloride for our molality. So we could go ahead and we'll start by going from our 100 milliliters of solution, and if we looked at the density of this solution, we would see that the density is 1.12 grams of solution per milliliter of solution, and that'd be something that we would be provided with, so we know the relationship between these two. And so now we see that we've converted to our 112 grams of solution. Well, if we have our 112 grams of solution, we know that that includes the water and sodium chloride. Well, we just want the amount of water. Well, we know in that 112 grams, we have 8.3 grams of sodium chloride in that 100 milliliters, which would be our 112 grams of solution. So if we just want to get to the mass of water, we can subtract our 8.3 grams of sodium chloride, and we end up with 104 grams of water. Okay, so now we have the mass of just our water. We can do a very direct conversion from grams of sodium chloride to moles of sodium chloride. Again, kind of doing this same thing right here using our molar mass. And so we could see we would end up with 0.104 kilograms if we want to convert that to kilograms, because we noticed that our molality units here are moles per kilogram. And we can go ahead and now calculate our molality. So you notice that I didn't go directly from our percent by volume to molality because of the difference in what we're describing as our ratio, because it's not grams or moles of solute per solution amount. We're dealing with solvent amount here now. So we can go ahead and we can convert, if we converted our grams of sodium chloride to moles of sodium chloride, which would be using our molar mass here, we would see that we would get 0.142 moles of sodium chloride, right? And that was just me converting my grams to moles. And then that's per the kilograms of the solvent here, which is our water, our 0.104 kilograms of water. And then that's now going to give us our molality, which ends up being 1.3 molality for our solution here. Okay. So we see we were able to convert from mass percent or mole percent or percent by volume, whatever we would want to each of these units. All we have to do is look at what is the ratio that we have relating these two. Okay, so we see a lot of these are ratios of amount of solute per amount of solution. So we'll notice really the only one that we're going to deal with here is our molality, which our molality is looking at the amount of solute per kilograms of solvent. Okay, so we notice that we're converting between those two. We really got to pay attention to that. Okay, so in the next video we're going to talk about colligative properties, and we're going to look at why do we want to use units of molality instead of units of molarity, or why are we going to use units of mole fraction instead of molarity or percent by mass or percent by volume.